AB-620, MCP integration in Copilot Studio, servers, tools, and governance. A lot of Copilot Studio integration decisions sound the same at first. The agent needs to reach an external system. It might call a connector. It might call a REST API tool. It might use a custom connector, or it might connect to an MCP server. For AB-620, the important question is not, can the agent call something? The question is, who owns the tool surface? How is it described? How is it secured? And how much control does the maker keep inside Copilot Studio? Here is the mental model for this lesson. MCP is a governed tool surface. The server publishes tools and resources. Copilot Studio connects the agent to that server. Then, generative orchestration decides when to invoke the available tools. So the chain is user intent, orchestration, MCP server, selected tool, external system, response back to the agent. Let's use Woodgrove Bank again. The bank has 5 back-end systems: core banking, loan origination, customer records, document verification, and compliance checks. Instead of every maker redefining the same APIs in every agent, the enterprise architecture team publishes a central MCP server called WoodgroveCore. The server owns the tool catalog. The account opening agent connects to that catalog. MIC stands for Model Context Protocol. It standardizes how AI systems interact with external tools, data sources, and environments. In Copilot Studio, an MCP server can expose tools and resources. Tools are callable functions like check account eligibility, verify identity, retrieve a customer record, or submit an application. Resources are file-like data or structured content the server can make available as context. The MCP specification also defines prompts, but Copilot Studio currently supports tools and resources, not prompts. The first exam trap is thinking MCP is always better than connectors or REST APIs. It is not. MCP is strongest when multiple agents need the same centrally managed tool catalog, when a platform team owns the server, and when updates should flow to all connected agents automatically. If the server owner changes a tool description, adds a parameter, or deprecates a tool, connected agents reflect those changes without each maker rebuilding the action one by one. Connectors and REST API tools are still the better choice when a single agent needs a specific integration, when the maker needs fine-grained control over each action's name and description, or when a deterministic topic must call the integration directly. That last point matters. MCP tools are invoked through generative orchestration. Topics cannot call MCP servers directly. If the design requires a topic to call the backend at a precise step, choose a connector, a custom connector, or a REST API tool instead. Now look at the onboarding path. For a custom MCP server, the maker opens the agent's Tools page, selects Add a Tool, chooses New Tool, and then chooses Model Context Protocol. The wizard needs a server name, server description, and server URL. The URL is the HTTPS endpoint for the server's streamable HTTP transport. Copilot Studio supports streamable HTTP for MCP connections. Older server-sent events transport is no longer supported after August 2025, so an older server must migrate before it will connect. The server description is not just a friendly label, it is a routing signal. The orchestrator reads the description to decide when the MCP server is relevant to a user request. A vague description like enterprise banking tools is weak. A better description says the server provides account lookup, loan origination queries, customer record retrieval, and document verification tools, and that it should be used when users ask about account status, loan applications, or customer details. Write it like a routing rule. Authentication comes next. Copilot Studio offers 3 authentication types for MCP server connections: None, API key, and OAuth 2.0. None is only appropriate for a fully trusted internal server where network-level controls are enough, and it is not a good fit for sensitive data. API key means each user provides their own key on first use, and the parameter name must match exactly what the server expects. OAuth 2.0 delegates sign-in to an identity provider and is usually the stronger production choice when the server and identity platform support it. OAuth has 3 subtypes to recognize. Dynamic discovery is the simplest when the server supports dynamic client registration with a discovery endpoint. Dynamic is for dynamic client registration without discovery, where the maker provides the authorization URL and token URL template. Manual is for identity providers that do not support dynamic client registration, so the maker provides client ID, client secret, authorization URL, token URL, refresh URL, and scopes, and coordinates the callback URL with the identity administrator. After the server is connected, the maker has one more important governance decision. Which tools should the agent be allowed to use? By default, Allow All is on. That means every tool the server publishes is available to the agent, and new tools can become available automatically. That is convenient, but it may be too broad. For Woodgrove's account opening agent, the server exposes 12 tools, but the workflow only needs 4: account eligibility check, identity verification, product catalog lookup, and application submission. Leaving the other 8 tools enabled creates orchestration ambiguity and violates least privilege. The maker turns off Allow All and enables only the 4 tools the workflow actually needs. This is also why tool descriptions matter so much. MCP tool descriptions are set on the server and are read-only in Copilot Studio. The orchestrator uses those descriptions to choose the right tool. If a description is vague, the maker cannot fix it inside the agent. The remediation path is to work with the MCP server owner to update the server-side description before production testing. Microsoft also provides pre-built MCP connectors for Microsoft services, including Dataverse, Dynamics 365, Outlook, GitHub, Teams, and WorkIQ MCP tools. For those, the maker can use the catalog path instead of manually entering a custom server endpoint. WorkIQ MCP tools can ground the agent in real-time Microsoft 365 context across email, calendar, and Teams, but they require the right licensing and administrator enablement. For the Microsoft MCP Server for Enterprise, the pattern is even more governance-heavy. It enables agents to query enterprise data in a Microsoft Entra tenant by using natural language. Setup involves tenant admin roles, Microsoft Graph permissions, app registration, OAuth configuration, managed identity or federated credentials, and a Power Platform environment that is not blocked by DLP. The exam lesson is not to memorize every field. The lesson is that Enterprise MCP is a managed security boundary, not a casual paste a URL integration. So what should you listen for in AB-620 scenarios? If many agents need the same centrally managed tools, think MCP. If the scenario says tool updates should propagate automatically, think MCP. If it says the maker must edit each action description, think connector or REST API. If it says the topic must call the tool directly, do not choose MCP. If it mentions Allow All, New Tools, Vague Descriptions, or Least Privilege, think MCP governance. The final rule is simple. MCP is best when the organization wants a shared, centrally governed tool surface. The server owns the tool catalog. Authentication protects the boundary. Tool descriptions guide orchestration. Allow All decides the governance posture. And generative orchestration is the caller. Keep those 5 ideas together, and MCP questions become much easier to reason through.